Hi, I'm Neel.
Hi, I'm Alisen.
Here's our circuit for part A. As you can see, we have a silicon diode followed in series by a 1 kilo ohm resistor. As you can see, as we increase V in, the voltage across the 1 kilo ohm resistor increases. From this, we can calculate the voltage across the diode, since that is simply the voltage supplied minus the voltage across the resistor. Using the voltage across the resistor and the resistance, we can calculate ID. And if we plot our IV curve for the circuit, you can see that it increases as such.
This is our circuit for part B, which is the same circuit in part A, except we add a capacitor of 0.1 microfarads in parallel, and the resistor value is increased to 10 kilo ohms. This is our waveforms. The ripple voltage is the voltage from the bottom to the top. This is our circuit without the capacitor, which turns the circuit into a half-wave rectifier, which does not allow the negative voltages to pass because of the diode. If we decrease the amplitude to 1 volt, or 2 volts peak to peak, we see that there's a bigger effect due to the inherent 0.7 volt drop from the diode, from a smaller input signal. This is our circuit with the op amp. We have the op amp here with positive and negative power. We have the diode from the output to the negative input, the resistor from ground to the negative input, and V in from the input to the positive input.
When we input a 1 kilohertz frequency and 1 volt amplitude sine wave, you can see that our output is simply half the wave. That is why this is called a half-wave rectifier. This is because whenever there are negative voltages inputted, the diode prevents current from running in the opposite direction. When we decrease the amplitude to 0.5 volts, which is less than V gamma, which is 0.7 volts, you can see we still get a half-wave rectification. However, if we did not have an active half-wave rectifier, the rectification function would be severely limited. When we increase the frequency to 10 kilohertz, you can see that our waveform has become a little distorted coming out. This is due to the slew rate of the op amp in this active half-wave rectifier, which is due to the capacitors within the circuit of the op amp.